In this particular question, you've been asked to evaluate a definite integral. The integral from 1 to 2 of x squared minus 2x plus 5 all raised to the 4 times x minus 1 dx. What I would recommend that you do is first work with the indefinite integral and then later evaluate the definite integral. This is a slightly different procedure than what you'll see in the textbook, but it's probably the most straightforward to deal with. So that's what I've done on my next line. I've written it as an indefinite integral, and I'm going to let u equal x squared minus 2x plus 5. Therefore, du would be equal to 2x minus 2 dx. And then if I rearrange and express dx in terms of du, I would have that dx is equal to 1 divided by 2x minus 2 du. So let's return to our indefinite integral. And so we have the integral of, instead of having the x squared minus 2x plus 5 raised to the 4, I'll now have just u raised to the 4, times x minus 1 times 1 divided by 2x minus 2 du. What I've done in my next line is I've common factored out a 2 from the 2x minus 2, leaving with 2 times x minus 1. In this form, you can see that we have an x minus 1 in the numerator and an x minus 1 in the denominator, and therefore, when I divide one into the other, I get a quotient of 1. So now my question becomes the integral of 1/2 u to the 4th du. This would give me 1/10 u to the 5 plus c, where c is an element of reals. And therefore, when I substitute back in for u, I would end up with 1/10 times x squared minus 2x plus 5, where all of that quadratic expression is raised to the 5, plus c, where c is an element of reals. Now, this would be fine if the original question had been an indefinite integral, but that's not the case. We were given an upper and lower limit, those being 1 and 2. So we now have to evaluate that definite integral. And that's what I'm showing on my next line. And when I do so, I end up with an answer of 210.1.